Hello guys, hope you're doing well. My name is Mahmoud Kiasrik and welcome to the new chapter of math or advanced algebra. So at this point, we would like to talk about a very interesting topic that maybe some of you heard of, some of you may not. And it is complex numbers, or at some point we know it as imaginary numbers. So first of all, we would like to talk about it. Why we do need those numbers? What is the problem that we have? Because obviously anytime we do have the solution or we do have a way to solve something, it comes from the fact that actually we had a problem. After that, we would like to do a couple of mathematical things, do some kind of calculation, have some definition, and at the end of the day, we would like to solve a couple of questions. So without further ado, let's talk about it. So the idea or concept from the complex numbers or some kind of a new term beyond than just normal line, because as we just know, so far we know everything related to the real numbers, 1, 2, 3, 4, anything related to fraction, negative side. We know everything about that. But what has happened that we need a complex plane? What has happened that we need a new form of line definition, a new form of number definitions that could help us to solve a couple of things? So the idea was simple. You do have an equation, x to the power 2 plus 1 equals to 0. And you would say that obviously this question is unsolvable. Why? Because as we all know, the power 2 of any number, doesn't matter what is that, should be positive. But if you rearrange this work, you do have x to the power 2 is equals to negative 1. Obviously, in order to find x, you have the root of negative 1, and root of negative 1 is what? I don't know. It's undefined, right? And I'm here to say that no, actually it's not undefined. It doesn't exist in the normal world, but it's not undefined. You are going to use that or to define a new term of numbers. So it means that in the universe of real numbers that we all know, there is no solution for this equation, as I just saw. The square of any real number obviously is going to be positive or negative, is always positive. So it doesn't matter. The square of any real number that you do have, it should be positive or negative. Negative 1 to the power 2 or 1 to the power 2. So they are going to be positive. To solve this, we just don't need new numbers. We cannot invent new numbers. We need more than that. So we need a new kind of numbers. That's why we do need complex numbers. That's why we need to have a definition for root of negative 1. For this definition, they came up with an idea that says that since root of negative 1 doesn't exist, why not declare or why not use a letter for that? And that letter is I, and at some point it's J. Doesn't matter, both of them are the same. So what is I or J? I is just a symbol that shows that root of negative 1 can be declared as something. So as you guys see, I to the power 2 is going to be negative 1. Root negative 1 times root negative 1 is going to be negative 1 itself. So again, why we are going to define a new number? This guy is going to be the single purpose and only going to be used to solve this problem. It means that every property of the complex system is built upon this unshakable foundation that we know it as I, which is the square root of negative 1. By the way, this kind of imaginary thing does not mean fake. They come up with an accident. So don't just think that this is just imaginary, just fake, and we just made it up. No, this is the actual and 100% and guaranteed way that we use in mathematical to solve our problems. So the four-phase cycle of I. So what does that mean? As you guys know, the I just by itself, by the way, I to the power 0 is considered as 1 just like any other thing. So itself not only is going to show you a vector, but it's also going to show you an angle, or going to show a direction. It means that I to the power 1, which is a normal I, is going to be 1 with the angle of 90. By the way, I will show you why. I to the power 2 is going to be what? 1 again with the angle of 180. I to the power 3 is going to be negative I with the angle of 270, and I to the power 4 is just normal I to the power 0 itself. By the way, how come we do have that? As you guys know, I is going to be root of negative 1 and I to the power 2 is negative 1. These are the two factors that we. What about I to the power 3 is multiplied by I? So it's what? I to the power 2 is going to be negative 1 times I is going to be negative y. Negative I. What about I to the power 4? Is what actually was I to the power 2 multiplied by I to the power 2. So we know that I to the power 2 is negative 1 and this guy is negative 1. So we do have it as 1 and everything is okay. By the way, maybe sometimes they would ask some question. For instance, what is the I to the power of 34? So the only thing that you need to do is just divide this number by 4. And whatever remainder that remains, you just compare it with any of these guys. And since you remember all of them, you can just keep the remainder and then you can find your answer itself. So let's talk a little bit about just some kind of the combination of real numbers and imaginary numbers, because as you know, especially when we were talking about the simplification of terms, if we do have two like terms, we can just add them up. We can do anything with them. But when we don't have two terms like saying x and y, we cannot do it. At this point, if we combine the real number, it's a real part, and another part that we call as imaginary, which means that there's a number that has the coefficient and also has an I beside of that, you cannot easily combine them. So the first component is going to be considered as just a normal one, just a real one. But on the other hand, we do have another component that is going to be beside our I, which means that our vector on the imaginary part is going to be something bigger than or smaller than 1. It's not just 1 itself. By the way, you should note that a and b are still real numbers, but when you combine the b and I, they're going to be imaginary parts. So the combination of these two guys is something that we know as complex numbers. In the future slide, we will talk about it, how actually we can show it in their specific plane, not a normal plane, in a specific plane, and how we can measure some numbers for them. So let's talk about the arithmetic, right? Let's talk about the addition and let's talk about the subtraction part. What does that mean? It means that we would like to add or subtract the two complex numbers. So imagine that you do have 3 plus 2i as one your complex number, and another one is 1 subtracted by 5i. So if you would like to add them up, what would happen? You would add terms, real parts and imaginary parts. 3 plus I and minus 2i minus 5i plus 2i. So you do have 4 minus 3i. How we can show it in the plane? In the future, you would see that the complex plane is actually like a normal plane. Instead of just having x and y, it has a real part and it has imaginary part on the y-axis. So for instance, if I would like to show 3 plus 2i, it means that I have to move 3 to the right as the real part and 2 to the top as the imaginary part. What would happen if I show 1 minus 5i? We are going to do the same thing, but we moved it over here because we would like to do the addition. If you add these vector, let's pick this vector, but from the physics, we do have 4 minus 3y, and as simple as that. So what about the multiplication? The multiplication follows a simple path or simple rule that we know that I to the power 2 becomes negative 1. What does that mean? It means that the multiplication of two complex number is very similar to the by two terms. When we do have two terms by two terms, first term by first term by second term by first term, and second term by second term. Is that so? You do have it like this: add 2 times 3, and then you do have 2 times negative I. You have I times 3 and you have I times negative I. So can I simplify this one more? Obviously, yes, because I do have negative I to the power 2. So negative I to the power 2 can be considered as negative 1 times negative 1, which is going to be 1. And if you handle or if you combine all of that, at the end of the day, you do have 7 plus I. By the way, make sure that you're not going to skip any step. If you just think that, oh, I can do it in my head. No, please do that because you need to have all of them. And this is the challenge of division. What does that mean? It means that if I do have two complex numbers like this, 2 plus I subtracted by 1 minus I, how I can do this division? Because normal or direct division doesn't work. And at this point, we are going to use a new term that we call it as the complex conjugate. What is a complex conjugate? Complex conjugate means that you do have the real number, and this complex conjugate means that A minus IB. That is the very simple term. How we can look at it in detail, just like this. As I just told you, the conjugate can be considered as a reflection across the real axis. It means that your real part is going to stay constant. On another hand, your imaginary part is going to see a negative sign beside of itself. So if we assume that z is equals a plus by, your z hat or your z complex conjugate would be a minus by. By the way, why we use that? Because if you multiply the number by its complex conjugate, at the end of the day, you do have a to the power 2 plus b to the power 2. The proof of that one is so simple because at the end of the day, your by times a is going to cancel out a times negative by. So what you have, a to the power 2 subtracted by b to the power 2 times I squared. So you know that I squared is going to be negative 1. So at the end of the day, you do have a to the power 2 plus b to the power 2. As you can see, this guy is a aha moment. Why? Because at the end of the day, if I can find a way to multiply the numerator and denominator by a number, I can make the denominator as what? As just a number, right? If I do have the denominator as just a number, I can somehow simplify it by using some kind of the numerator itself, and everything would be fun. So let's see it in action. Imagine that we do have the question 2 plus I divided by 1 minus I. So obviously you see that how we can do it. The only thing you have to do is just multiply your numerator and denominator, but what? By its complex conjugate. You're not doing anything, because at the end of the day, this guy divided by itself is going to be 1, right? So if you do that, you do have this number on the top, and you do have this number on the bottom. So then what you got, you do have 1 to the power 2 plus 1 to the power 2 is going to be the denominator, and that's really fantastic. It means that I do have 2. Then I do have a numerator itself. So the numerator would be just a normal multiplication of 2 terms by 2 terms, or FOIL. At the end of the day, I do have this. So 1 plus 3i divided by 2. The good thing about the complex numbers is that they are still considering the real part as themselves. So I do have this one, 1 divided by 2 is going to be the first side, and 3 divided by 2 is going to be the second side. As simple as that. So let's talk about the new plane, a new form of number visualization that we know it as the complex plane. As I just told you, in the normal condition, we had x, we had y as our axis in just normal real numbers. If you do have a note, if you do have some kind of a point, it obviously has x and y, so we are going to use that. But at this point, we do have a new part. We do have real part and imaginary part. Again, the concept is simple. The only thing you have to do, just use the real number as your x-axis, which means that at this point I have to move 3 to the top, and you're going to use some kind of the imaginary or 2 as your imaginary part, as you consider as a y-axis. So by doing that, you can show any complex numbers on your complex plane. As simple as that. Nothing is strange. Obviously, whenever we're talking about the vector, we have to think about two things. The very first one is the distance, is about hypotenuse. In the Pythagorean theorem, you know that the combination of the a and b can somehow resemble as Pythagorean itself. Since right now I do have a as my x-axis or real part and b as my y-axis or imaginary part, and at the end of the day, this module, some kind of we call it as modulus, or we can say it as magnitude, or we can say as length, is going to be root of a to the power 2 plus b to the power 2. At the end of the day, I would like to see what is the distance from the beginning of the point to the end of my vector. Not only I have to know that, another important thing would be about the angle itself. As you can see, this guy, this some kind of main module, and the x-axis is going to make an angle that we call it as the theta. So the theta, or something which sometimes I call it as argument, is just showing you the direction between your main vector and the x-axis itself. And how we can find that? Simple. As you guys know, the theta or the tan of theta can be considered as the opposite over adjacent. So the theta itself would be tan inverse of b over a. By the way, you have to be very careful about the quadrants, because the tan and inverse of a function on a calculator typically only gives you an answer about the quadrant number 1 and quadrant number 4, right? Either positive or negative itself. But you have to look at the sign of a and b and determine the correct quadrant and adjust the angle if necessary. So at the end of the day, we do have something we call it as a polar form. It means that the normal complex form that we had, that z was equals a plus ib, can be written into another form that has the modulus and it has an angle itself. Sometimes they show it like this, and sometimes they show it like this. So what does that mean by each of them, by the way? The first one is simple. It's just about the modulus, about the amplitude, and about the angle, about the argument. The second one, z times e to the power j theta, is another form that we show it, the e as an Euler number, and j, or I have to say, because I just told you sometimes they would say j, sometimes they would say I, especially in electrical circuit, because I is the symbol of current, they would just show it by j. So at this point, we do have the z itself, we do have the a to the power I theta or j theta, and at the end of the day, we do have this. As you can see over here, if I would like to convert my polar form to the normal complex form, I need to find this guy and I need to find this guy. So cosine of theta, we know that this part is theta, obviously, is going to be what is going to be adjacent. It means that a, or the real part, divided by your z, or your zy. So I can say a, or the real number, is z cosine of theta itself. What does that mean? It means that if I do have the magnitude and if I do have the argument, the only thing I have to do is just multiply the hypotenuse, or by what? By cosine of theta. And I do have the same scenario for what? For my b guy.
That's why they're going to show it like this, because in the end of the day, sometimes you have to convert the polar form to the normal form, sometimes you have to convert it back. We know both ways, so this is just a way that we do have. So that was everything you need to know about the complex numbers. As you just saw, the whole concept was to start with a very simple question. The power 2 plus 1 equals to 0. We don't have any answer for that. That's why we have to come up with a new form of numbers. We know it as complex numbers. We saw how you can combine them with the real part. Obviously, you cannot combine it simply. We can just put them inside. You can just put them by together. We know it as a complex form. Then how you can add or subtract and how you can multiply and divide was very important. And at the end of the day, how you can show it in the real form, how you can show it in the real world using the complex plane, and you have two forms, the polar form or normal complex form. For the next chapter, we would like to talk in detail about the questions and what would happen if you do have different kind of form of numbers, and what would happen if you would like to solve them. Again, if you have any question, I would be more than happy to answer that. Don't forget to put comment me down below. My name is Mahmoud Kesari. Have a great day, night, whatever. See you around.